And let's keep moving on these. You want to get lots of different practice. And let's work on this one over here. So we have 2y minus 3 is 3y squared minus 10y plus 12. And that is all underneath the square root. But the square root is already solved for, so let's just square each side of this equation. And on the left-hand side, we'll need some more room for this one. On the left-hand side, we'll rewrite 2y minus 3. Since we're squaring it, we're multiplying that expression by itself. And on the right-hand side, we have the square root and the square canceling each other. So you get 3y squared minus 10y plus 12. And now we just simplify. We are going to distribute the 2y to each term and the minus 3 to each term. So you get 4y squared, and then minus 6y plus 9 is equal to all of this. And we want to move everything to the same side. So actually, I probably should write those so that we can subtract or add what we need to from each side. So let's move everything to the left and set it equal to 0 since we have a quadratic. And we'll either want to use factoring or the quadratic formula, or sometimes we can even solve by taking a square root, but usually that's not the case. So we will subtract 3y squared, we will add 10y, and we will subtract 12 just so that this side becomes 0. So we have minus 3y squared plus 10y and minus 12. Now on the right-hand side, we get 0, as expected. On the left, this becomes y squared. We get minus 12y if we combine these, plus 10y, so that's minus 2y, and then we have minus 3. Now this equation here, we can try factoring, since many of these problems will factor. It's just if you're not sure what to do, if you're not sure if it factors, you can always use that quadratic formula. And since the coefficient on y squared is 1, we don't have to use the grouping method. We, of course, can do that. But there's a slightly faster way where we essentially just do the reverse of the distributive property. We know that these first two numbers, or first two terms, are going to multiply to be y squared. And since the coefficient is 1, this will just be y and y. And then these last two terms, for the two binomials, these are going to multiply to give us negative 3. So what we can do is look at the list of numbers that multiply to negative 3. And that's either 1 and minus 3 or minus 1 and 3. And then out of these pairs, which of them adds to the coefficient on y, this negative 2 here? And that would be the 1 and minus 3. So we get plus 1 and minus 3. And at this point, you could check this, make sure you factored it correctly, and you do that by just remultiplying everything out. You distribute the y and distribute the 1 to both terms in the right expression. But we'll assume it's true. And now to solve this, we'll use our zero product property. Since it's equal to 0, we just want to ask which y value makes this expression 0, and which one makes this one 0. And so here we can do negative 1, and here we can do 3. So y is negative 1 and 3, but at this point we need to go back and check our answer, since we might have these extraneous solutions. So from here, let's check our answers, and we can first check negative 1. And basically, we're going to be looking at the equation before we squared each side, so the 2y minus 3 is equal to the square root of this. So let's plug in negative 1. 2 and negative 1 would be negative 2 minus 3. And on the right-hand side, we have 3 times negative 1 squared, and this is all under the square root. So that would be negative 1 squared is positive 1, so you get 3. And then minus 10 times negative 1, that's plus 10. And then we have plus 12. And so this is minus 5 is the square root of 25. But you can see this isn't true since minus 5 is not equal to 5. So negative 1 is not a solution. And we're going to check negative or positive 3 now. So let me change colors here. Let's do x is 3. And we get 2 times 3, which is 6, minus 3, which is 3. And this will be equal to 3 times 3 squared. And actually, I just realized I wrote x instead of y. So let's change that really quick. we were setting y equal to -1 and y equal to 3 here. So we'll do 3 times 3 squared, which is 3 times 9, and then minus 10 times 3, so that's minus 30, and then plus 12. And when we simplify here, 3 times 9 is 27, minus 30 would be negative 3, but negative 3 plus 12 is 9, and this is correct. The square root of 9 is 3, so we know at least one of these solutions made sense and worked when we checked it, and negative 1 was an extraneous solution. So we can put y is equal to 3 into the box. And from here, we're going to look at some more advanced problems now where the equation is not solved for the square root term. So for these problems, we'll just need to do that. We will need to solve it first for that square root term, and then we'll solve it the same way. So I'll rewrite this. We have that y is 3 plus the square root of y squared minus 5. And we need to solve it for the square root term. So let's just move the 3 to the other side. We can subtract 3 on each side. And we get y minus 3 is the square root of y squared minus 5. And from here, we'll just need to square each side, just like before, to cancel out that square root. And after squaring both sides, on the left, we'll rewrite this as y minus 3 times y minus 3. And on the right, the square and the square root cancel, and we get y squared minus 5. Now we can multiply this out. We get y squared minus 3y minus 3y, so that's minus 6y, and minus 3 times minus 3, which is positive 9. And let's subtract y squared from each side, since we have the same amount of y squareds on each side, so we can turn this into a linear equation. And what we're left with is minus 6y plus 9 is negative 5. And so let's work on this up here. We could subtract 9 on each side of the equation. We get minus 6y is minus 5 minus 9, which is minus 14. And dividing everything by negative 6, we get minus 14 divided by minus 6, which can be simplified. It becomes positive. And dividing each by 2, we get 7 over 4. And at this point, we could, that's 7 divided by 3. And at this point, we could plug our answer back in to make sure it makes sense. But we're thinking that it's choice letter C, or it could be no solutions. This might be an equation where this is actually an extraneous solution. So let's plug that back in to our original equation here. So we will check this when y is 7/3, and so we get that 7/3, that's over here, is equal to 3 plus 7/3 squared, and we'll subtract 5 from that, so we get that 7/3 plus the square root, that would be 7/3 equals 3 plus the square root. This becomes 49 divided by 9, and we'll subtract 5 from that, but let's do a common denominator. We'll give it a denominator of 9. So we multiply 5 by 9, that's 45. And let's keep simplifying here. So this becomes 4 over 9. And we're taking a square root of a fraction, so we can take the square root of the numerator and the square root of the denominator. And so that 7/3 is 3 plus 2 for the square root of our numerator, and 3 for the square root of our denominator. And 3 plus 2/3, we'll want to change that to a denominator of 3 as well, so this becomes 9/3 plus 2/3, which is 11/3. And 11/3 and 7/3 are not equal. So this one actually has no solution. This was not the correct answer. And so for our multiple choice here, we would use choice letter E.